Hello, Toronto. I am really, really excited to be over here with all of you today. I'm Christopher, he, him pronouns, and I'm going to be talking to you about how JustEatTakeaway.com load tests using Grafana Cloud K6. But first, a little bit about myself. I'm a senior site reliability engineer at JustEatTakeaway.com, and I'm located across the pond over in the UK. I've been working here now for about 7 years, and in that time, I've been in a selection of different teams. I started out in the product engineering space, but gradually over the years, I've made my way to platforms, where I found my home in the platform assurance team. In this team, we provide reliability tooling to over 2,000 colleagues in product and tech. And as you can probably tell by me being here talking to all of you today, I'm really passionate about performance testing and ensuring overall system reliability. Outside of work, though, I really enjoy photography and playing video games. And for any gamers out there, I do have a maxed account on RuneScape. But a quick look at the agenda today. I'm going to give you an introduction to JustEatTakeaway.com, who we are, how you might know us over here in Canada, where else we operate, and why reliability is critical to our business. This will lead us into the importance of load testing, and more importantly, what can happen with the absence of load tests. I will then discuss how our platform has evolved over the years and how we have adopted Grafana Cloud K6 and the benefits it has brought us. And then finally, I will cover how we actually load test at Jet and finish off with a couple of key takeaways. JustEatTakeaway.com is a leading global on-demand delivery company. We have over 350,000 partners, and these are located across 16 different countries. All of these partners are then used by over 60 million active customers, and in 2024 alone, we delivered more than 500 million orders. But of course, I'm over here with all of you in Canada, where you will know us as Skip. As I mentioned, we are in 16 different countries, but across these countries, we are spread across 10 different time zones. Throughout the day, we are processing thousands and thousands of orders. For us, uptime is key, and ensuring we can handle peak level load throughout the entire day, that is critical. And that's going to be a key focus of my talk here with you all today. So, load testing involves putting an application or a service under varying levels of load and monitoring its performance as you do so. But why? Why do we do this, and why is this actually important? That is a question I'm hoping I can answer for you all today, and I'm hoping that by the end of this talk, you have a strong desire to want to implement load tests or performance tests within your own organizations to improve your reliability posture. But before I can jump in to exactly why it's important and give you them answers, I first want to talk about how we handle architecture at Jet, specifically application tiering. Every component that gets deployed into production on our platform is given a tier, ranging from tier 1 components all the way to tier 3. Our tier 1 features are those that are critical. They are required for the core operation of our business. Or without these features, we are holding a legal or a compliance risk. Essentially, without a tier 1 feature, our platform cannot operate. But on the other end of this scale, we have tier 3 features. These add additional user functionality. They improve the experience, make it a bit more fun to place an order. But without these, we can still process orders, and at most, there'll be a minor revenue or conversion impact. But what this means is a tier 3 component should not, in any way, be able to cause impact to our tier 1 or tier 2 components. And with that out of the way, I'd like to introduce you to our analytic service. This is a tier 3 component at Jet, and therefore, by them definitions, it is non-critical and it should not affect our tier 1 or tier 2 components. And this service, it handles a lot, and I mean a lot of data. Over 750,000 requests per minute at peak. And recently, it did a migration. It moved from legacy EC2 infrastructure over to EKS. And don't get me wrong, this is a migration we are actively encouraging teams and engineers to do. We're all seeing more and more improvements in containerizing applications. But this team did it without any load testing in place. To give you a quick overview of what this looked like, you can see the EC2 and EKS deployments here. For both of these, the traffic enters our platform through the same API gateway, but the route it follows afterwards is drastically different. For our EC2 deployment, traffic goes from that API gateway to a dedicated application load balancer, after which it does what you'd expect a load balancer to do. It distributes it among the various EC2 instances. But on the EKS side, it's very different. We go from our API gateway inside our EKS cluster to our Istio gateway. And this pushes the traffic through our virtual service, our service, to the underlying pods. However, as well as serving traffic to our analytics service, it serves traffic to other applications in the same cluster. Application A, application B, they follow that exact same flow. The migration that was done, it was not a big bang migration. We didn't suddenly throw all of our traffic at the new set of infrastructure. It was done gradually over the course of a week or so, monitoring the performance every single night of our analytics service. So why am I telling you about this? And like all good reliability stories seem to start, it was a Friday night back at home in the UK. People were finishing work. They were getting home, ordering takeaways, ordering groceries, maybe even ordering some flowers for their partner. And that is exactly what we saw. Our evening started with orders coming into the platform. Things were looking good. We were doing what we were meant to do. The Istio gateway that I mentioned had a horizontal pod autoscaler configured. And this allowed a maximum of 5 pods to come into service. We were starting our evening at 60% of our capacity, 3 out of 5 pods. Not terrible, not amazing. And the evening continued. We saw more orders coming into the platform. And with orders comes a lot more traffic to our analytics service. Customers are interacting with different pages or different areas of our website, and every single action reports analytics. So to handle this, a 4th pod scaled in. Now this was a good Friday night for us. More and more orders and more traffic kept flowing into the platform. And to handle this, a 5th pod came into service. Unfortunately, at this point in time, one of the underlying nodes that these pods were scheduled on, it started seeing very high CPU usage. And that is when our very happy and successful Friday night very quickly became a very sad Friday night. Our on-call teams were being paged. We saw a drastic drop in incoming orders to our platform. One of these 5 Istio gateway pods, it had been taken out of service, and that put the remaining 4 under increased load. If you remember what I said just now, this Istio gateway did not just serve our analytics service traffic. It served traffic to our tier 1 features behind it, those critical for core business operations. And I would love to be able to tell you this was the end of the story. But our evening continued with a further drop-off in incoming orders and a 2nd pod being taken out of service. The 2 nodes these pods were being scheduled on both now had excessive CPU usage. We had 3 pods serving what at least 5, seemingly a lot more than 5, were needed to do. And it's very safe to say our platform, it was struggling at this point in time. We engaged our on-call teams. They were able to help manually scale us out and perform other key actions to recover the platform. But to this day, this was still a drastic hit. Our hungry customers were unable to order their deliveries. But to our business, this incident still remains in the top 5 largest incidents we have ever encountered. So to summarize, we are not load testing to celebrate every single success. We are not load testing to celebrate every green light or green tick you get from your CI processes. We load test to highlight failures early. And I can safely say, in this incident I just shared with you, the same issue would have been caught time and time again if load tests had been utilized. Now I want to make it clear, I am not blaming in any way the owning team for this. We have a blame-free culture here at Jet, and at the time of this incident, Tier 3 services, they weren't considered for load testing. It was not considered a non-critical feature could have such a widespread impact on our platform. So we took away a lot of learnings from this, changes to how we architect our platform to protect from this. But more important to today, changes to how we performance test at Jet, which led to our eventual migration to Grafana Cloud K6. And I know, you all want to hear more about K6, and I promise I will get to it. But first, I want to talk about how we have been load testing at Jet. This is not in any way a new concept to us. So meet Rambo. This is an internally developed service made back in 2016, and it consisted of a test orchestrator, a cache, and a cluster. This orchestrator would spin up short-lived tasks in our ECS cluster, and these tasks, if they had to communicate, had a Redis cache to do so. Originally, Rambo was created to support JMeter load tests, but we wanted to evolve it over time, so we added support for Taurus, and then for artillery, and this, it improved the engineer's experience. But then we kept adding more features. We wanted to make it better and better, sometimes in response to platform incidents to safeguard us. And overall, Rambo became bloated and really hard to maintain. It served us well, but we knew we were in need of a replacement at this point. So we started looking for one, and we wanted to make sure we took a user-centric approach on this. We did not want to pick a tool out of a hat, throw it to our users, and hope for the best. So we conducted user research to understand their needs, their challenges. And once we had this, we could set up an internal proof of concept. This allowed us, in the platform assurance team, to understand what it was like to maintain this service. But more importantly, it let us test it with real users, which is exactly what we did. We put this proof of concept in engineers' hands. We gave them a couple of scenarios to test, and we gathered feedback, what they liked, what they disliked, sometimes what they absolutely hated. But based on all of that, we were able to make an informed decision on the best tool for our users. After that, we had to deliver it. We have a lot of complex systems. In an organization this large, there's a lot of things to improve engineers' lives. So we integrated it, and then following that, we're on to the adoption phase. The bit we all know tends to be the hardest in platform engineering, getting users on the tool, deprecating the old one. But we did all of these steps, and we were able to select our tool, which I'm sure is no surprise, we picked K6. We got a huge amount of feedback from our engineers during our testing phase. But the most important thing that came from this, K6 was not a tool picked for our engineers. This was a tool picked by them, a tool they wanted to be using. So we have now adopted K6 across Jet, across Skip. It is our global tool for performance testing, and we encourage engineers to be using it every single day. But how are we actually utilizing this? And I'd like to start off by talking about pipeline testing. What you can see here is your standard CI/CD pipeline. The application gets built, some unit tests are ran, security scans, deployed to QA, to staging, exactly what you would expect. But we have implemented a new step, run K6 tests. And quite simply, it does what it says on the tin. A selection of tests will be ran for our teams. As a result of this, they will get immediate outputs, telling them were their response times within defined thresholds, were there increased errors, and did any custom checks they set up, did they succeed? In this situation, they all did. So this unblocks the pipeline. It allows them to deploy into production, knowing that our users will get the best experience possible. However, if any of these had failed, the pipeline would stop. It would prevent a faulty deployment going into a production environment. It would prevent us breaching our SLOs, impacting our customers' experience. Alongside pipeline testing, we run a weekly analytic stress test. This is an action from that incident I shared with you earlier, and it reaches excessive load. Over 17,500 requests per second are hitting our analytics service. And this runs once a week on a schedule to confirm that that same incident we had before cannot reoccur, but that any new incidents from platform architecture changes, from changes made to the underlying service, have not impacted our platform. If the team needs to run this to gain any assurances of their real application, they can run it whenever they would like. We also run what we call order flow tests. These are individual tests that run across all of the countries we operate in, testing our application and our web flow, that tier 1 flow, the critical components on our platform. This again runs on a schedule, and we use this to validate changes. Per week, we have over 1,100 changes made on our platform. That's a lot of change deployed all the way through QA, through staging, into production. So validating this gives our stakeholders the assurances they need, and the assurances that we can handle peak level traffic the upcoming weekend. Now, all of these tests I have shared with you, all of these pipelines I have shared, there's one other thing about them. At Jet, we do not only load test in QA and staging. We run all of our load tests in production environments. And this is something we encourage all of our engineers and all of our teams to be doing. We want to embed this in their software development lifecycle. Teams shouldn't be scared of production. It should be an environment they use to ensure that real customers are not affected. And standing here today, I will admit, it will seem terrifying to run a test in a production environment. But all of that fear is what makes it worthwhile in the end when you see that little green tick saying it succeeded, saying that your response times were perfect, no SLOs got breached. So to summarize how we are load testing, we offer pipeline testing to teams to encourage them to shift left as much as possible. And we encourage them to run their tests throughout their pipelines, through QA, through staging, and finally to run their tests in production. Teams can run scheduled tests to get continuous feedback as to how their applications are performing with change, not just their own change, but the wider platform change. And if a team needs to run an on-demand test, they can do exactly that. They're empowered to run their tests whenever they believe they are needed, in whichever environment best suits their needs. And all of this we achieve using Grafana Cloud K6. Out of the box, we get a huge set of curated dashboards. Every screenshot you have just seen, we got out the box. We did not have to make anything custom. But if we needed to dig deeper into any of these results, we can do exactly that. We can understand which endpoint is having poor performance compared to others. We're able to set up thresholds for our tests, which allows them to be stopped automatically in case of any breaches. And when you run a test in production, that's pretty critical. No engineers are needed to stop the test. If response times breach your threshold, or you see an increase in 503s, terminate automatically. Prevent real users being impacted. We get given 21 unique load zones to run from, meaning we can test in a load zone relative to our users. For Canada, we test in Canada. For the UK, we test in London. Whatever will best represent our traffic is what we will use. And we are also able to set up an internal load zone. We have a lot of internal endpoints. They should also be getting tested. And then, out of the box, we get given a GitHub Actions integration, which, from minutes of installing it, you can have a workflow set up running a test in Grafana K6 Cloud. These are just some of the features we're using every single day with Grafana and with K6. So to summarize and leave you with a few key takeaways for today. No service runs in isolation. Load tests will help you uncover ripple effects across a variety of different services. As an engineer, you may really strongly believe, your service shouldn't impact any others. The only way to be certain is by having a test in place. Your tools, they should be there to serve your engineers. We took a user-centric approach in selecting K6 as our new globalized load testing service across Jet and across Skip. And for us, this resulted in a huge adoption rate. Teams are excited to use a tool they had selected, instead of being given a tool that was selected for them. In fact, we even had teams coming to us asking, can we be an early adopter of K6, while we were still setting it up? And in platform engineering, you don't often see that, so it was a very different feeling. And finally, confidence lives in production. All of us here today love our staging environments. They help you get assurances pre-production. But the real test is, and always will be, how your production environment handles load. All it can take is one minor difference between staging and production, and you invalidate that whole test run. Be brave and run your tests in production, and you will get the assurances you need. I hope this has been useful for you today. Thank you.